How's it going, everybody? In this video, we're going to take a look at our next video, which is actually going through and installing our first ESXi host. So this process is going to take me a while to do, and I'm not going to make you guys watch me do it. So once I do it once, it'll pretty much be the same thing over and over and over again, which, again, I'm not going to make you guys watch. I am going to go brief overview of what it is that we're going to be doing, just because it's, well, time consuming. So we're going to be going ahead and creating a virtual machine that's going to be running ESXi 6.7 update 1. I'm going to give it 4 CPUs in order to do its job. I'm going to give it 16 gigs of RAM, 40 gig thin provisioned hard drive, and then I'm going to set the IP address to be 172.168.1.11, but I'm going to give it a default gateway IP of the HSRP address so we can ping that IP. So without any further ado, let's go ahead and bring this guy up and start the process. As you can see here, I've got my CSRs up and running. I still haven't figured out how to get rid of this, but it's not a showstopper. It's more of just an annoyance. So everything's good to go there. I'm going to go ahead and minimize this. I'm going to click back over here, and I'm going to install the ESXi hosts sequentially, 1 through 6. So in order to do that, we're just going to go ahead and create and register a VM, create a new virtual machine. We're going to say the guest OS is other, and we're going to go all the way to the bottom for 6.x. I'm going to click on next, provide a name. Oh yeah, that would help. We're going to do, in this case here, it's going to be DC1-ESXi1. Now, eventually, I do plan on having multiple data centers when I do this, so we can do things like multi-site and NSX federations. But that's a long way down the run. So nothing in the immediate future of what I'm going to do. I'm actually running 2 labs at the same time so I can test things out and learn them, and then anything that I don't already know how to do, I'll be demoing later. I'm going to go ahead and click on next. I'm going to say, actually, you know what, back this up once. I'm going to put in here NSX. There we go. Because I'm leading with NSX for everything. I'm going to click on that. Next, DS2 is fine. I'm going to give this 4 procs. And underneath here, we need to expose the hardware-assisted virtualization to the guest OS. If we don't do that, it says enables full CPU virtualization by exposing hardware-assisted virtualization features of the underlying processor to the guest operating system. Now, essentially, what that's going to allow me to do is run a virtual machine inside a virtual machine running on a physical server. That's what they refer to as a nested environment. Now, VMware doesn't support this in production, obviously, but I have multiple times demoed a nested virtualized environment to customers to show them what the capabilities are, so that they can get an idea of what it is that they're going to be buying or what we're going to be deploying, things like that. So, because then it's 30 seconds for me just to open up a remote desktop session to my lab, and if I've got a customer on a call, I can be like, this is what we're going to be doing, and walk them through the process. So, that's going to be needed right here in order for this to work. If you don't do that, you'll never be able to boot up a VM that we're going to be deploying instead of these ESXi hosts. I'm going to go ahead and click CPU back up. I'm going to give this guy 16384, which is 16 gigs of RAM. Hard drive is going to be thin provisioned. And then I'm going to go ahead and give it not 1, but 1, 2, 3, 4, 5, 6, 7, 8 NICs. Now let me take just a moment here, and I'm going to zoom in a little bit tighter on the network adapters, just because of the fact that that needs to be explained a bit more in detail. Let me go ahead and get out of the way. Now, the first 2 NICs are going to be management, right? That's pretty obvious. So first 2 NICs are management. The next 2 NICs, NIC 2 and NIC 3, are going to be storage. That's what these guys are going to be right there. And then the 5th NIC, or VMNIC 4, that's going to be for vMotion, so we can move a virtual machine from one ESXi host to the other. Then NIC 6, or in this case here NIC 5, VMNIC 5, our 6th NIC, is going to be for data. So when we go ahead and deploy vCenter networking, I'm going to be tying everything, all the data, um, all of the virtual machine data interfaces. Their network adapters are going to be mapped to that specific VDS port group once we get there, and that's going to allow us to go through the deployment process. Now, I'm going to be deploying 6.7. 6.7 Update 3 is the lowest version of ESXi you can deploy with NSX-T. You can't go any lower than that. I've tried. So, and when you do that, you have no choice. You must deploy the NSX-T VDS. This is a dedicated host switch that when you go to install the NSX VIBs, when you bring the ESXi host into NSX Manager and you go to push the VIBs that are going to get installed on the host, in the process of doing that, you're going to be pushing an NSX-T enabled switch. That switch is basically going to be tying both your VLAN back segments and your overlay segments to that host switch, and that host switch is going to have uplinks, VMNIC 6 and VMNIC 7 respectively. Now, what that's going to essentially allow us to do, it's going to give us physical NIC redundancy outside of the rest of the network. So think of it like this. If you've got ESXi host running 6.7, any version of 6.7 up to 7.0, whatever the latest release of 6.7 is, whatever that last update or patch is, anything 6.7 from general availability all the way to the latest and greatest patch, you must use an NSX VDS, or what we refer to as an NVDS, N-VDS. When you go to 7.0 or later, you can actually install NSX to the VDS itself, as long as you're running a VDS of 7.0 or newer. Any VDS running 6.6 or older, you can't do that. So 7.0, if you want to run the VDS and NSX at the exact same time, you can. That is what was done with NSX V. So back where NSX for vSphere. Well, NSX-T for data center, they changed it up a little bit, and you needed dedicated NICs for your NSX configuration. Now, that allowed you to run your traditional VDS port groups and still use your uplink for your existing deployment, right? Then if you wanted to do a migration slowly but steadily from VDS port groups to NSX port groups, whether they were VLAN backed or overlay, you'd be able to start doing the migration, one VM or one bank of VMs or whatever it is that you wanted to do at a time over to NSX-T. I'm going to show you guys how to do that. It's actually a pretty easy process. Well, what's cool about it is when you migrate over to straight NSX, it gives you a little bit more flexibility because you get some functionality you wouldn't get in the VDS port groups. We'll talk about that more later. But if you're dealing with any version of ESXi 6.7, you must have dedicated network adapters if you're going to be running NSX-T. If you don't have availability, and a lot of customers that I work with, they don't have open network adapters on their servers. So I had a customer just recently that was going through the same issue, and I said, okay, so here's the caveat. If we, as we're going through this, what we'll need to do is upgrade your ESXi hosts and your vCenter to some version of 7.0. That way here, you'll be able to bring your ESXi hosts and vCenter. You map vCenter as a compute manager to NSX Manager, and then the clusters and the hosts that are a part of that particular vCenter start showing up in the inventory of your transport nodes, which is what basically any of your compute nodes are for ESXi. We'll talk more about that in detail later and what exactly that means. But you can then install NSX-T directly to the VDS itself. And so when I do that, I often will work with my customers so that we are taking and we're creating more VDSs, and then we're mapping them appropriately so that we're installing NSX-T to specific VDSs that are going to be, it's not an additional NVDS, right? It's not the dedicated NSX-T VDS that gets pushed from NSX Manager. This is a vCenter VDS that's got the extension of NSX-T attached to it. And normally what we do is we create dedicated VDSs for any for the NSX VDS. We deploy that with NSX bits to it so that we can then start mapping workloads to the NSX enabled VDS port groups, take advantage of the capabilities of NSX without having to worry about dealing with an additional switch that is there because it has to be. And the cool thing about it is you can, if you've already got your existing network adapters set up, if you already have existing VDSs that you want to roll with, that's great. We don't have to go ahead and mess around with the physical side by adding more 4-port switches to the back of your host. We don't have to go ahead and disassociate a specific VM-NIC from a VDS and then rearrange your networking. We don't have to do any of that rigmarole. It saves us a lot of pain and time. I have had customers that needed it though. It's a time-consuming process because sometimes you've got VDS port groups that are mapped to a specific uplink. Then you got to adjust that. Then you got to go ahead and yank the VM-NIC from the VDS port group so that then it's freed up for NSX-T, stuff like that. It can be challenging. I'm going to do my best to walk you through some of those scenarios where when we get into 7.0, how that'll come into play. Now, what's cool is every once in a while I get the question, can I move everything to NSX? And I'm like, yeah, you can. You can treat it just like a VDS connection. So if you've got your management and your storage and everything else, you can migrate all of that over to NSX. I don't recommend it though. What I do recommend is keeping your infrastructure services, things like management, storage, vMotion, fault tolerance, things like that. I recommend keeping that on dedicated VDS port groups and then leveraging Network I/O control NIOC version 3 for anything infrastructure. Anything that the ESXi host itself needs should stay on a VDS port group. That's just my opinion, and then the VM kernel adapters. However, you can migrate your NSX, any of the stuff that's sitting on existing VDS or VSS port groups, you can migrate that over to NSX-T, the VM kernel adapters as well. It's very rare that I have customers that need that. I don't recommend it, namely because of the fact that it's complicated. And it's like, okay, why do you want to do that? I asked that question, and sometimes I never recommend it as a solution, but if there's a specific scenario that they bring up, then I'm like, okay, let me test that out first, especially if it's not something that I'm comfortable with or have ever done with. If I'm knowledgeable on the capability, but I've never actually done it, I'll go ahead and lab it up. But most cases, most customers don't ask for that. They're will often create a new VDS with dedicated network adapters so that we can basically do the connectivity that we need to. Now, you don't have to, like I said, you don't have to do that. You can take an existing VDS that's already rolled out and just push NSX bibs to it, and then start pushing segments, but whether they're VLAN backed or overlay, down to the ESXi hosts. It changes the way that things are done, though. There's some connectivity stuff that happens. If you're going with an NVDS, there's certain MTU things you have to set up in the back end that you don't do when you're using a BDS, an NSX-enabled VDS. And we'll talk more about that in detail later when we do the upgrades to ESXi 7 and vCenter 7 and go through and then do an NSX 3.2 upgrade. So we'll take a look at exactly what that looks like down the road. So with that being said, though, you and I are going to go ahead and finish this connectivity, but I want to talk a little bit about the network connectivity because it's kind of a big deal. So you can do VMware networking in one of two ways. The first way is what you see here, where you've got all your network adapters set up. Maybe you've gone out and bought, a 4-port or an 8-port NIC expansion card, a mezzanine card, or whatever it might be, a mez card as they sometimes call it, or a daughter card, and you install it in your server, and then that's what you're going to use. You're going to use dedicated uplinks to do what you need to do. You're going to do per NIC service separation. That's possible as well. Oftentimes, that's not the case, though. I do this because of the fact that I don't have a way to do any trunking. Well, I technically could do it, but I typically don't like to because it confuses people when I do it. Whenever I do just a 4-port connection, or I do a 2-port connection, and then I try to do VLAN specific segmentation, but I tie it to the same port groups, it does work, but it gets complicated. I oftentimes get a lot of feedback where I don't get it. It's really just trunking at the end of the day. You're tagging a VLAN, and then it's going upstream to a switch, and then you're tagging it. Any real world networking that I do on the VMware side, I have usually between 2 and 4 NICs that I get to work with, and I have to make everything happen on 2 or 4 NICs. And obviously, I have 5 different services right here on the screen that I need to work with. So, but that's why I typically do it the way that I do. I create a single VDS, I map all of my port groups to it, and then I go through and make sure that everything stays load balanced when you do that. As long as you have all your port groups mapped to all your network adapters, you're in pretty good shape. So, and we'll talk more about the number of adapters that you can map when it comes to NSX-T. So for every physical uplink you have for NSX, you're going to get 2 VM kernel adapters, or 2 TEPs, tunnel endpoints. But we're going to talk more about that in detail when we get into the actual NSX deployment and why it works the way that it does. So that's the networking capability, and we've talked through the resources that we're going to be assigning. So let's go. I'm going to go ahead and get out of the way. I'm going to minimize this. I've got that, so I'm going to go ahead and add. I need a total of 8 network adapters. Oh, and just for clarity's sake, let me go ahead and zoom out. So ESXi 1 through 4 are going to have 8 network adapters, right? 2 for management, 2 for SAN, 1 for vMotion, 1 for data, and 2 for NSX. When we get over to ESXi 5 and 6, we're going to have, it's not listed here, we're going to do 2 for management, 2 for storage, and 2 for uplink. And the reason why I'm doing it that way is because, technically speaking, we don't need, I could on the management, I could do vMotion. I could add vMotion as an option there for testing purposes and do an anti-affinity group. But for storage, I don't need vMotion on my edge devices, and we're not going to be installing NSX-T on these hosts right here. We're simply going to be using the uplink as connectivity, both for connections via the overlay connectivity once we get that up and running, as well as uplink connections to the CSR 1000 Vs for the VLAN back segments that we're going to be using for edge node to top of rack device, or your border gateway, whatever that might be, to connect it out to the rest of the world. So we'll talk more about that from a logic flow and how the traffic will flow through the network, but that's essentially what we're going to be doing. So let's go ahead and get that process started. I'm going to go ahead and get out of the way again. So I'm going to add 7 adapters. So that should be 7. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. And I'm just going to turn all these into lab port group. Just like that. All right. So now that I have that done, I'm going to go ahead and change the host device. It's going to be data store ISO file. And I'm going to choose 6.7 update 1. I'm going to select that, click next, and then finish. All right. So the next thing I'm going to go ahead and do, I'm going to click on NSX ESXi 1. I'm going to go ahead and click on the power button, and this bad boy is going to start. So this is going to take some time for it to install. So I'm going to pause until we're at a screen to interact with. Okay, so we're at the point now where we can interact. We're going to click on enter to hit the OK, and then F11 to accept the end user license agreement. Right now it's going to look for a hard drive to install to, which it should find that 40 gig hard drive, which it does. We're going to set the password. Same password I've been using this entire time. Just like that, hit the enter key. Now it's going to scan to make sure we get the right capabilities. So it says we're going to be installing ESXi 7. We're going to hit F11, and we're off to the races. So I'm going to go ahead and I'm going to pause the video until the install is done, and then we're going to reboot and boot to ESXi. Alright, so we're about to reboot now. Hit the enter to reboot. It's going to reboot, and it takes about 5 minutes or so for it to come back online, so I'll see you in just a moment. Okay, so we rebooted, so I'm going to go ahead and hit F. That also happens to be my pause button, so it pauses the recording. So I had to make sure to re-enable the recording after I hit F2. So I'm going to go ahead and type in the password, and then we're going to go down to Configure Management Network, hit the enter key. Network adapters, we're going to come down and 0 and 1. IPv4 configuration, set a static address. We're going to type in 172.31.1.11 slash 24 mask. And then 172.31.1.254 is our gateway. Hit the enter key. Then DNS configuration is going to be this guy, and then it's going to be 172.31.1.254. And then it's going to be dc1-ESXi 1.nsx.local. Enter key, hit escape to reset the management network. Yes. And then we're going to go down to test management network. Hit the enter key, and we're going to give this guy a row. Oh, I didn't think about that. Okay. So, my DNS server IP address and my default gateway happen to be the same IP. So I'm going to change my DNS server to be .253. Not that big of a deal. I'm going to hit the enter key, and I'm going to go ahead and pull that guy up real quick. And I'm going to, let me go ahead and get out of the way. I'm going to go ahead and adjust that IP real quick. I hadn't thought about that. I was like, wait a minute. That IP address sounds awfully familiar, guys. Yeah, we're going to change this guy to be .253. Just so that I don't make the mistake of, there we go. Close, close. Perfect. Alright, so I'm going to go back over here. Minimize this. And test management network again. Actually, escape. I'm going to go to configure management network, DNS configuration, 253. Escape. Yes. Test management network. Ping address. That should go through, hopefully. Failed. Okay. Every once in a while that does fail. Not sure why it does though. Doesn't make any sense to me. I don't technically need a gateway for that though. Okay, let me just see the CSR real quick. Can I see the show standby brief? Okay, .2 is the active. Show ARP. Okay, I don't see. Oh wait, yep. 2. Show ARP. I see the IP, so let me go ahead and ping 172.31.1.11. That guy can ping. Okay, let's try this one more time and see what happens now. Sometimes you might have to do an ARP flush. I don't know how to do that on ESXi. I'd have to go Google that. But nevertheless, okay, I'm not going to worry about it though. So that's okay though. Our ESXi hosts themselves don't actually need to do anything. They don't need to connect outside to the outside world. So what we are going to do though is we're going to go, that's the end of this video. I'm going to go ahead and get the other 5 hosts deployed. And then once that's done, I will go ahead and get the storage array deployed. So with that being said, I want to thank you guys for stopping by and hanging out with me. If you haven't already done, please leave a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.